listeners, chemistry, and welcome to Chapter 6, Section 6.4, where we talk about counting molecules by the gram. So really, and even molar mass is not a new concept here, right? We're just talking about the molar mass of a compound as being something that is new, right? And it's really the same concept, right? Where this is still the mass, right? Mass equal to 1 mole, right, of that particular substance, right? Just now we're going to add all the pieces together. So, for example, if we were talking about nitrogen dioxide, right? If we were talking about nitrogen dioxide, we would have to sum all the pieces together, right? So I have 1 nitrogen, and if we look at our periodic table, it has a molar mass of 14.00 grams per mole. I have 2 of these oxygens, which is 16.00 grams per mole. And then I would sum all that together, right? So I would have 14 plus 32. And when we add, right, so this is just like x's basically, right? So this is like 14x and 32x, which gives us x. Yes, does that make sense? Going back to like math. So 46 grams is equal to 1 mole of NO2, right? So however you want to write that, right, we would put each piece wherever it belongs. But that is how we do the molar mass for any substance, right? So if we were to look at something more complicated, like so magnesium nitrite, for example, right? So here that we have NO2 again, but it's stuck to a cation, which means that it's a polyatomic ion and not the molecular compound nitrogen dioxide, right? So here we would have 1 magnesium at 24.31 grams per mole, and we would have 2 nitrogen, so 2 and 14, and we would have 2 times 2, so 4 oxygen, and all of that would get summed together to give us the molar mass of magnesium nitrite. Yeah? All right. So then, doing some practice. So we're going to calculate the number of moles of NO2 in 1.18 grams. So I have a given of grams and a goal of moles. Do I know a conversion factor between moles and grams? I do. Molar mass. So 1.18 grams of NO2. We'll go back. 46 grams are equal to 1 mole, right? And we've done our work, yes? And we would take 1.18 divided by 46.00 and get our right answer and round it to 3 significant figures, yes? All right, how many H2O molecules, so this is clearly our goal, are in a sample of water with a mass of this? So this is our given, which is a mass, right? And I'd like to get to molecules. Is there a conversion factor between mass and molecules? No, we have to stop at Avogadro's number on the way, right? So 3.64 grams. Let's go ahead and get the molar mass, right? So we have H2O, right? Which is going to be 16 plus 2 times 1.01, right? Which gives us 18.02 grams equals 1 mole for water, right? So we have 18.02 grams of H2O for every 1 mole of H2O. And then for every 1 mole of H2O, how many molecules are there? Correct, 6.022 times 10 to the 23rd molecules of water. And then we would just need to do the math. Yes? Does that make sense? All right. Thank you for listening. Be good, and I will see you soon.